If I told you there is a place outside of Earth with lakes and rivers, the first thing that would probably come to your mind is water. Because as far as we know, lakes, rivers, and rain only make sense with one thing: water. All life on Earth, all ecosystems, and even civilizations have found life around water. That is why when lakes are mentioned on another world, our minds inevitably take Earth as a baseline. But where we are about to go, things are not at all what we are used to. There really are lakes here. There are rivers. There are deltas. There are clouds. It rains. The seasons change. Winds blow. Yet water is not at the center of all this. Because the temperature here is about minus 179 degrees Celsius. At this temperature, water completely loses its fluidity and turns into an ice rock as hard as granite. Just like the rocks we step on here on Earth, water serves almost the exact same purpose on Titan. So what is flowing? The answer is quite surprising. Methane and ethane. Methane, which is one of the primary components of natural gas on Earth, exists in a liquid state in Titan's freezing cold. It rises into the sky, turns into clouds, falls back down as rain, feeds the rivers, fills the lakes, then it evaporates again. In other words, an almost exact replica of Earth's water cycle occurs on Titan with methane. That is why Titan is not just Saturn's largest moon. It is like an alternative Earth project prepared for us by nature. Here, physics is the same. Chemistry is the same. Gravity depends on the same universal laws. But the temperature is so low that all the roles change. What is a rock for us becomes a gas. And what is a gas turns into a river. This is exactly what makes Titan unique. Titan is Saturn's largest moon. With a diameter of about 5,150 kilometers, it is even larger than the planet Mercury. However, unlike Mercury, it has a thick atmosphere. In fact, it is the only moon in the solar system that has a truly dense atmosphere. About 95% of this atmosphere consists of nitrogen. What is interesting is that Earth's atmosphere is also largely composed of nitrogen. So, the core component of Titan's atmosphere is actually not foreign to us at all. But the remaining part completely separates the two worlds. There is methane in the atmosphere. Ultraviolet rays from the sun and high-energy particles from Saturn's magnetic field break down this methane, creating hundreds of different organic molecules. Over time, these combine. They evolve into more complex structures. Eventually, thin orange particles form in the atmosphere. This is why Titan looks golden yellow or orange from a distance. Actually, we cannot see the surface. What we see is an organic haze layer that reaches kilometers in thickness. For many years, this was the reason why scientists knew next to nothing about Titan's surface. Optical telescopes could only see this layer of haze. Titan was hidden behind a thick curtain, so to speak. Everything began to change in 2004 when the Cassini spacecraft arrived in the Saturn system. Cassini started to examine this atmosphere, through which visible light cannot pass, using radar systems. And for the first time, Titan's true form was revealed. Mountains, valleys, riverbeds, large lakes, even coastlines resembling those on Earth. These images astonished the scientific world, because never before had such Earth-like geological structures been seen anywhere else. However, what flowed here was not water. In 2005, the Huygens probe entered Titan's atmosphere. It descended by parachute for hours. Humanity had succeeded in landing on the surface of a celestial body in the Saturn system for the first time. In the photos taken during the descent, dark lines resembling river branches could be seen from above. When it reached the surface, the cameras showed a landscape covered with rounded stones. These stones looked strikingly similar to river pebbles on Earth. There was only one difference. What eroded them was not water, but liquid methane. Most of the lakes on Titan are located in the polar regions. Some of them reach hundreds of kilometers in width. The sea called Krakenmeer is large enough to be compared to the Caspian Sea on Earth. Other large seas, such as Ligeia Mare and Punga Mare, are also filled with a mixture of liquid methane and ethane. Radar measurements show that some of these lakes could be hundreds of meters deep. Waves can form, coasts can change over time, The amount of precipitation can increase or decrease according to the seasons. In other words, an active climate system is at work on Titan as well. So, how is all this possible? Because Titan is located very far from the sun. Sunlight reaches it at only about 1% of the energy Earth receives. Despite this, the atmosphere is so complex that even small amounts of energy can create major climate events. Methane evaporates, clouds form, precipitation occurs, the surface is shaped. Later, the liquids reach the lakes again. This is called the methane cycle. In fact, everything except the name reminds us of Earth's water cycle. Although Titan's surface appears frozen, what actually catches the attention of scientists is beneath the kilometers-thick ice crust. Gravity measurements and tidal movements suggest that a global liquid ocean could exist here. It is estimated that this ocean does not consist entirely of water. It probably contains a significant amount of ammonia as well. Since ammonia lowers the freezing point of water, it could help the ocean remain liquid for billions of years. If this is true, it means there is an ice layer hundreds of kilometers thick between Titan's surface and its deep ocean. This situation is different from Europa. While Europa's ice crust is thought to be thinner, Titan's ice crust is much thicker. However, the variety of organic molecules that Titan possesses makes it extremely valuable for astrobiology. Because a major part of the basic building blocks necessary for life to emerge form here through natural processes. This is the biggest reason for scientists' interest in Titan. Today, we do not know for sure how life on Earth began about 4 billion years ago. However, it is thought that methane, nitrogen, and various organic gases might have been present in Earth's atmosphere during that period as well. Titan, on the other hand, offers us a frozen laboratory of these chemical processes. It is as if the chemistry of Earth from billions of years ago has been preserved in time. That is why Titan is not just a moon. It is a natural research center where we try to understand the first steps of life. Perhaps the answer is hidden not on Earth, but inside this orange world spinning silently around Saturn. For this reason, NASA's Dragonfly mission is not viewed as an ordinary space mission. This 8-rotor, nuclear-powered vehicle will fly for kilometers in Titan's atmosphere and land in different regions. It will analyze the soil. It will examine organic molecules. It will measure the atmosphere. And perhaps, it will find clues that can answer one of humanity's oldest questions. How did life begin? Because sometimes the greatest discoveries are hidden not in the most distant worlds, but in places where the rules we know are completely rewritten under different conditions. And Titan is exactly such a world.